Mr. Raneses, where are you? Oh, what's the heart rate? Heart rate?
Regular.
100. Oh, Miss Eka, where's Miss Eka?
2, 3.
Where's the PR interval? What's the PR interval?
1, 2, 3, 4, 5, 6, 7, 8, 9.
100.
What's the PR interval? Jasper. Is this regular or irregular? Regular. Okay. So what's the PR interval? Beginning of your P, the beginning of your Q. So what is it? Who knows? What's the PR interval? Point. Now.
12 to 20.
12. Pag 0.6, abnormal na yun. 0.04 yan per square. Okay?
0.04.
What? Ano man? Sagot.
1.
0.6? 0.16. So what about your QRS? What's the duration of your QRS? Mr. Ranches. QRS, ilan?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15.
12. Okay. Answer. Your heart rate is 100 beats per minute. Why? Using your square method, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay? So 1,500 divided by 15 is 100. Your pattern is regular. If you put a piece of paper, mark this, and then transfer that paper here, the interval between your R and your R will be the same. So that's regular. PR interval is 0.16. Beginning of your P at the beginning of this one, it's 1, 4, 8, 12, 16. QRS complex, beginning of your Q to the end of your Q. So this one, the entire square is 4. This one is part of one square, part of another square. So that's actually 0.08. Okay? 0.04. 2 squares mo yan. That's basically 2 squares because this one is half of that square and half of this square. And this one is one entire square. So 0.408. Okay, so that's normal. Because it does not occupy the beginning of the square.
0.40.
You estimate it as part of 2 squares. Okay? So the answer is 0.08 seconds. Now, rhythm. You have a normal heartbeat.
0.04.
Sinus rhythm. Then you have fast heartbeat, which is what? Tachycardia lang. Because when you say sinus, what does it mean? Sinus, it means that your waveforms are present, especially your P waves. Okay? So your P, your QRS, your T, and that's a sinus one. Okay? Then you have your slow heartbeat, which is what? Bradycardia. Then you have your irregular heartbeat, which is what? Your arrhythmia. So you can also have a fast heartbeat that is irregular, so that is what you call a tachyarrhythmia. You also have a small, what you call a slow heartbeat, which is irregular, so you call that a bradyarrhythmia. Okay? Now, ECG interpretation. Check ECG waveforms, determine rhythm, determine PR, QRS, and QT. Axis, that we usually determine that, but not now. ECG tracing. Okay. What do you think is the heart rate of this one?
Inverted QRS.
If we use the quadrant method, this is one example. So 300, 150,
100.
So the heart rate. If we use the square method, 5, 10, 11, 12, 13, 11, 12, 13, 14, 15. So 1,500 divided by 15 is still 100. So you have your 1 in ABL, 2, 3 in ABF, B1, B2, B3, B4, B5, B6. This is a normal ECG. Usually your T, Q, or ST are upright on this views. Okay, 1 and 2. ABR, the QRS complex is usually inverted, as well as your T. If it's upright, then there's something wrong with the way you place your leads. Okay? V1, the QRS complex is negative. Your your T wave is usually upright. But as you go along V1 to V6, your QRS complex becomes upright. Okay? Another ECG tracing. This is the normal ECG. Okay? So when you read an ECG, you look at how if your P, QRS, T are present, if your rhythm is regular, your RR intervals are regular, you get the heart rate, you get the PR interval, the QRS, and the T and the QT interval. Okay?
Inverted pa rin ang QRS.
Next. Oh, this one is another example. So again, for this one, this is still within normal. As you go along, it becomes positive. Okay. If you notice, this one is not flat, right? Not unlike this one, not unlike this one. That is the reason why you have to know your ST segments, because if this was elevated like this, okay, one very quite high, then that's already significant. This one is not, it's still within. Oh, what about this one? What do you see?
Hindi inverted ang QRS sa AVR. Yung QRS complex
Saan?
sa AVR1.
What else? AVR is upright. Therefore, this is a wrong ECG placement, so you cannot interpret that. You have to repeat it again. Okay, this is wrong. You cannot interpret this as myocardial ischemia, anteroseptal wall, because these 1T wave inversions are ischemia in ECG interpretation. But you cannot interpret that because this one is wrong. This is upright. Okay, when this one should be inverted, and V1 should be inverted.
Yes.
So this is an example of sinus bradycardia. It means that your PR interval is normal, your QRS is normal. However, your rates are slower than the usual. What's your normal heart rate?
60 to 100.
60 to 100. Anything lower than that is bradycardia. Anything higher is tachycardia. Okay, usually the heart rates, you have atrial rate and ventricular rate. If your rates are regular, it means that your ventricular rate is the same as your atrial rate. However, when it becomes irregular, when your P waves are different from your R waves in a different, for example, in atrial fibrillation, in other conditions wherein the heart rate is different, then you have to write the difference, atrial rate and ventricular rate, separately. Okay? Now, this one is sinus tachycardia. You still have your P waves, your QRS and your T, but your heart rate is fast. Okay? So, you have your sinus tach. Now, this one is sinus arrhythmia. You have your P, your QRS, and your T, but your RR intervals are different. And a difference of one small box, that is insignificant. A difference of one big box, on the other hand, that is significant already. So, your rhythm is irregular. When you have sinus arrhythmia or arrhythmia per se, you always put your heart rate in range. Okay? Let's say the widest and the narrowest, you compute that, that's your range. Then this is an example of your AP blocks. That's the reason why your PR intervals are important. If it's more than 20 seconds, it's around 24, that's already first degree AP block. Okay, so atrial fibrillation, your pattern is fibrillatory for your atrial, this one. Okay, but you still have your QRS complexes. But your atrial complex or your P interval, that's where the problem lies. So your heart rate is actually 350 to 650. In atrial fibrillation, we read it as either slow, rapid, or moderate ventricular response. So that we do not place any ventricular rate. So this is a normal rhythm. This one is a VTAC or ventricular tachycardia. This one is a very bad tracing. This is another abnormal ECG. We see this in myocardial ischemia or myocardial infarction undergoing evolution. Nice to know. Now this one is an example again of VTAC. Okay. This one is VFib, ventricular fibrillation. Okay. So this one is irregular. After ventricular fibrillation, if the patient does not recover, it results to ventricular assistance. When that happens, then you take care of the patient thereafter. Okay? So any questions? I'm going to distribute certain ECG so we can work on that. Group 1, 2, and 3, you can go to the last room. So you choose one member from your group to have an ECG. Unfortunately, because of the setup, it's not ideal. So we have to have a male volunteer for this, not females. Because females, you have to remove your upper blouse. So that's not allowed. Okay? So because of the setup, you can only do the males. So one per group. Group 1 is your representative. Group 1, 2, and 3, you can go to the last room. Have your ECG done. While the other groups, you can start borrowing your BP apparatus. If you have a question, BP taking is very easy. So just complete it. If you have a question on how to do it, raise your hand so I can go and see.